We will talk today about MySQL storage engines. So MySQL has practically maybe even unique among databases. It has pluggable storage engines. It has many of them. It has many of them, and actually that's probably users can be a little bit confused. So why the storage engine interface and which one to use? So okay, so we have here some slides. Okay. So I can. Okay, so. That's introduction. It's a little bit about me. I'm MySQL support engineer since year 2006. I'm author of book MySQL Troubleshooting. I'm doing some kind of development, and I'm doing speaking. And today talk, I want to start from history. MySQL first very popular version was, it was not first MySQL version, it was a very popular version 3.23. And before that, MySQL had only one engine and called it ISAM. And 3.23 introduced table types and famous MyISAM table engine. Then it also had Berkeley engine and also has other engines at that time. And in year 2003, German type was deprecated, and and everyone started to call MySQL engines. But that time, engines were built into the server. So if you want to create new one, or if you want to modify existing one, well, you cannot do it independently, but you cannot ship it independently from MySQL source code because it has to be built in. It was actually there were some companies who tried to do business this way, but that still it was not very good for users, and not because just you have to. You cannot just install, you cannot be truly independent. And version 5.1 changed everything because it introduced pluggable storage engine, and this leads to a huge growth of number of independent storage engines for MySQL. It's another part of history. This is InnoDB. InnoDB was MySQL engine much before. Long before version 5.1. It was the built-in storage engine. First time it was released as MySQL storage engine in March 10, 2001, version 3.3.24. Before MySQL, it was originally developed as standalone database, but around that time, Monty and Heikki, who was original creator of InnoDB, that's called it InnoBase that time. And they discussed it, and what I heard, Monty persuaded Heikki to be part of MySQL and make business like this. In year 2000, but that time, InnoBase, who created InnoBase and the InnoDB storage engine, was independent company, and the MySQL was independent company. In year 2005, InnoBase was acquired by Oracle. And development of InnoDB continued, but again, as I said, it was hard to make revolutionary changes for built-in storage engine because the built-in engines correlate to server part is more tight than the pluggable one. And InnoDB had major changes in 5.1. It introduced new table space format, Barracuda. Introduced dynamic logic of engine, and first online operation, it was online index creation. And this in a version of InnoDB was released as plugin. So it was first shipped separately, but then shipped together with MySQL, but as plugin. Actually, two versions existed in versions 5.138, 5.173. One is built-in, fully compatible with 5.0, And second is pluggable. It's actually fully compatible with 5.02, but that time when it first was introduced, it was some like kind of decision if it's risky or not. And in version 5.1, only one version of InnoDB stayed in the server. That's one which based on pluggable version. There are many other businesses which started producing independent MySQL storage engines. And pioneers, most notable that time, were TokuDB and Primebase. Actually, I believe both started their business even before pluggable interface, but with pluggable interface, they sounded a lot and became like, it really were very notable. TokuDB provided write-scale TokuDB storage engine. We will have talks about TokuDB. And this company was acquired by Percona, and TokuDB storage engine for MySQL is alive. It's a full-featured storage engine, and you may use it now. Primebase as a company, it still exists, but engine which it created for MySQL now discontinued. It called it PBXT. Their product on which engine based it's still exists, but it just doesn't. They don't work on MySQL storage engine anymore. Which was interesting, they tried to create better large object handling technology, but there is no such engine now. At the same time, in the official distribution, all built-in engines, it was like memory, CSV, and the others were actually unveiled before, but they were converted into plugins. And old engines, some old engines were removed. It's BerkeleyDB and ISAM. In community, number of engines is growing, and sometimes it's like, here are examples, it's not like kind of like engines who work closely with data and closely with disk I/O, like Spider provides a sharding interface. It can has underlying any storage engine. It can provide sharding for MySQL. Connect just uses any source of data, so it can be XML file, it can be ODBC, it can be anywhere. Federated X is a better version of federated storage engine, which exists in MySQL and which is known famous for its bugs. Sphinx search engine is storage engine is interface for Sphinx full text search search server, and there are actually more engines. Among vendors, MariaDB I think includes most of MySQL engines. So if you that's PDF will be available on Percona Server website. I'm sorry, Percona Live website, and these are clickable links, and you can go to documentation of these engines. That's regarding introduction. There are also concepts of simple and complex engines. So all engines actually supposed to store data and retrieve data, but simple engines usually do not override anything else. So from built-ins, and everything are done by server. Like, for example, logging, for example, MyISAM, which is really a simple storage engine, it doesn't have its own logging, it's made on server level. Same for transaction supports, and 5.5 supports transactional server level, but actually they are only for metadata logs, not for anything else. There are also built-in diagnostics like check table or show engine status, and simple engines usually do not override these things, but may override. Complex engines, they implement or own logging model, or own transactions, own diagnostics, or own log files, and actually everything. And today we will discuss three major storage engines for fully functional. It's InnoDB, TokuDB, MyRocks. All three are transactional. All three support row-level locking, multi-version concurrency control, ACID, distributed transactions, and automatic crash recovery. This one in different ways. InnoDB is a universal storage engine and fits actually for most workloads. It's default science version 5.5.5. TokuDB is write optimized, so if you need fast writes and you can live with slower reads. It has good compression support and very good for when you need a big amount of data. MyRocks also it's write and space optimized. It has great compression support. I will explain it a little bit later. And it's best for modern storage, which is fast but expensive, like SSD. InnoDB uses for access B-trees. B-trees, they allow to it's actually fast read access. I have picture later, and I will show you why. But on each write, they need to be rebalanced. And actually, other engines, when I speak about write optimized, they do something with this downside of InnoDB. InnoDB has rich feature set like foreign keys. It has low-code engine level, and unlike many knows about row logs, and actually it has gap log, after increment log, it has table logs. It has compression, although it's not so great like in other engines. It's again a little bit later. And it has best crash recovery. So it has automatic crash recovery, but if automatic crash recovery, you can set up, you can say InnoDB just to skip one part of crash recovery and let server start, and then make a dump and save your data which is not corrupted. Percona Server also has options how to deal with corrupted pages, if ignore or print warning or this. So what is B-tree? Actually, this is wrong B-tree. It's not balanced. It should be here. It should be live here. So I leave. But let's assume we have like it's here. It's but it still can show concept. So when selecting like 11, we just take root. If we select some value which is less than root, we go to left part, which is everything which is less than root, it's on the left, which is greater than root on the right. So to select 2, we just go step down, and to select 9, we go step down. So that's just single path. So that's very easy to read. For writes, it's, everything goes not so easy. Because for writes, at first you need to read to find out where to put this new value. So it goes somewhere here. Then you have to put it. So first we check, so put it here, but it's greater than 5. We have to move 9 somewhere. So we are moving 9, we are moving 10, we are moving 11. So and we put it here. So this actually we move. We just rewrote all 3. So it's in worst case it can be a lot of writes. It's what is also not good. It's kind of random writes, and if on disk it can be. So it's especially on hard disk, it would be time for seeking a place where to write this. TokuDB uses fractal tree. So what is a fractal tree? So it's if to say it's very short, it has like some kind of buffers where data written in sequential order, and then background process call it checkpointing. It's just flashes everything what are in these buffers into actually it's kind of B-tree. But for this you have pay priced reads, because it cannot be just to go down. It's like that's not flashed data. It's shot in buffers, and TokuDB has to implement, has to search this. not checkpointed data. But TokuDB has optimization for reads. This means it's secondary clustered index. So what is clustered index? Clustered index, it's an index which contains data. It's like primary key in the DB. It's just points, just has each index, value in the index just points to the row. In clustered index, it's not space efficient. That's why I said it's RocksDB is space efficient, but TokuDB is not. So it's can be like 2 times table size, but it's better, but it's faster reads. Read-free replication. That's case if you have primary key in the table, data from master can be applied without trying to find the row. So it's just primary key access. With read replication, it's good. You can replicate, for example, from master which uses InnoDB, and also. But you cannot write on the server. And due to design, there is no less index less index fragmentation than in case of InnoDB. Optimization for writes, it also has fast, it has bulk loader for optimization for load data in file. It has faster inserts. It also has multiple level of compression, and again, due to design, what InnoDB does with compression. It stores data in pages, and it's when it has data, some data is compressed. It's less than a page, but some gaps states. If next chunk of data it cannot be put on the same page, so this space is not used. For TokuDB, this is not the case. It's just compress everything. There is very effective compression, and also it has more compression algorithm than InnoDB. So other features, it has really rich set of log diagnostics. It like, for example, it has offline diagnostic for log wait timeouts. It's cases that there is no dig log, but when your transaction just one waits for timeout, and just when you see error message, please consider restarting your transaction. But it has no foreign key support. Crash recovery is fully automatic, and until latest version, you could not any kind of influence it. For the latest version, we just introduced a tool which can somehow step into recovery process. But until late, you could just like if TokuDB cannot fix the crash, fix the corruption. It's cannot start the server. It's no matter if you have one table is not corrupted, one table is corrupted, you still have to restore from the backup. MyRocks has LSM tree. It's one more B tree based tree, but optimized. So how it works? It all writes go to memory table and write ahead log file where it's sequential read. Write ahead log file use it for in case if like some corruption happens and it has to restore. Data files itself are immutable. When again checkpointed process happens in MyRocks, MyRocks takes data from write-ahead logs and from mem table and put into data files. Data files put are in 4 levels, depending from size. There is also there is also a compaction for these data files, and you can specify compression level for any level of these files, and it's very satisfying. And also designed it for small transaction. It's because all writes go to memory table and all in memory, so you cannot change gigabytes of memory in a single transaction. It has optimization for reads, like Bloom filter, which in case if you should not go to, you can get data without reading. It's just give you. It has reverse column family, so you can have descending index even 5.6. And it also has read-free replication. It has options for bulk operations, very good compression. And it has limitation. It has only 2 transaction isolation levels. So TokuDB and InnoDB have 4. No gap locking, so you cannot write queries which were less than or greater than. No support for foreign keys, full text keys, special keys. And index access for limited types, so it's actually with collation Latin 1B, UTF-B, and binary type. Crash recovery again is limited. It's only if write-ahead log file is corrupted. If your data corrupted, it would not recover them. Here is comparison, the comparison table. Here I say want to mention your compression. It's different in all. It's valid. All engines are supported. So best compression in MyRocks and highest tunable. It's very effective. TokuDB is same effective, but you cannot effective regarding space, but you cannot fine-tune it in such a way. So like for MyRocks, you can set up some data can be not compressed, which is highly accessed. For rarely accessed data, it will be compressed. InnoDB is actually more simpler compression, but otherwise it's more future rich. And summary, MySQL has many storage engines which provide a lot of flexibility, extends server functionality, and there are many simple and complex engines exist. InnoDB is best for many workloads. TokuDB are best for write and intensive applications. And on this conference, we will have many in-depth storage engine sessions. It's just like now, goes in Ballroom B, MyRocks engineering, deploying new MySQL storage engine to production. And tomorrow we have this session, so I'm out of time, so I just like show for you using Spider. We have on TokuDB session tomorrow. And today I want to invite you to all about ROCks BOF session at 6 p.m. Where I invited everyone who speaks about RocksDB, MyRocks, and MongoRocks. Thank you.